Hello guys, welcome to another session. This is Golang. Yep, we're going to be starting from the beginning, and the idea of this is that we want to write RESTful API. That's the idea. But before we start writing RESTful API, we need to get some basics out of the way in terms of programming itself. I assume that you know a little bit about programming. This is not your first programming language. So, but I will try as much as possible to introduce the fundamental as much as possible. Okay, let's clear everything and start off anew. So you already have your ID set up. Your favorite ID, you can bring it up. I'm going to be using VS Code. Yep. And it's the RAE that I'm using, but still a clone of VS Code. So what I want to do here now is to to start up a new project. Let us start up a new project and see how that works. What are we going to call our project? I don't want to call it test. Let's say we have a new folder. All my project is inside this app, and we can call it API for now. That's what we'll call it. So you can call your project anything you want, and let's see, and let's go ahead. We already deduced that our file extension, our first file should be main.go. We already deduced that, and everybody agrees with that part. And we also talk about the fact that things are done in packages. We write our program in packages, like so, package dot main. The reason why it's bringing API is because it recognizes the folder name and is trying to maintain the folder name thing, in its place. Now the next thing is we have to write function main. You have to continue with the main thing, and then you execute. So these are our typical program. Okay, so let's go in more in depth and try to talk about other parts of Go. We already deduced this part and we are good to go in this part. There are things you need to get yourself accustomed with, and that is variable naming and storage. I won't go ahead to talk about what variable means. You should already know the importance of variable in programming language. This is not programming language 101. Instead, it's supposed to be how you can harness Golang to do, to program. Okay, so how do you declare variable in Golang? And this is where our app starts from. Of course, you can branch out from here and call more function, right? We should be used to something like that. You can write and then call your function from here. So these are our entry points into our app. This part can branch into several dimensions. So here we can declare a variable by using the var keyword. A var keyword is used to declare a variable. So I'll just flow with the AI what is giving me. What this one means is that you are declaring a variable A, and it's supposed to be an integer. That's what you are saying. There are various ways in which you can declare a variable. So you can either say this. Let's just make it so that it doesn't give us that error anymore. So what you've done is that you've declared a variable and you've used it. The reason why it was giving us issue was because it's not being used, right? So now we declare it, we use it. This is one way of declaring a variable. Another way of declaring a variable is to just specify, let's say, name, and we use column equal to, and we consume the variable directly, or we give it a name. CRE. Okay, let me just use steps, right? So this is another way. Of course, we have to say name here so that we can remove that error there. But this is just variable declaration. You can use any of this format to create variable, and we are good to go on that. What are the variable types that Golang supports? Golang supports vast number of variables, right? It has things like So because I'm going to be writing a lot of things here, so I'm going to put in comments so that it doesn't mess up our code that we're doing. So we're already introduced to int, which is something here, and we have int. We have let me see if it will be smart enough to start listing them for us. We have int 32, and so don't let me make it complex. I will just go as simple as possible. So we have int, we have several forms of int, we have float. The idea of 32 or 64 is how the integer needs to be. So we have float 64 and 32, I suppose. Then we have our infamous string. We have our boolean. We did this in Python. Boolean is true or false. And again, I will not explain too much of all these things. So these are the primitive types, and you can create your own types later. We'll get to type creation later, and then you can define all these things. So these are the common ones. Now let's look at other forms of variable declaration, and that's what I call constants. Constant. What are constants? These are things that will not change. So if you want to create um, a variable that will not change, you use this method. Of course, this is creating a group constant. This is not what I had in mind. So if you want to just create something constant, like without you doing all those things, just do something like this, right? So this is a constant, is a keyword. I is the variable name now, and then automatically you assign it to this. So this cannot change. You cannot reassign it to something else. That is the purpose of this one. Again, your constant can be a string. It doesn't have to be a float. In this case, it's a float. Yeah, you can define it to be a string. So you don't need to predefine your type of constant. It will just automatically know that my constant is having this data type, and everybody's good to go. Okay. Now we've done variable declaration. We need to move on to something else. Like I said in the beginning of this class, this is not trying to teach you programming language. I assume that you are a programmer, you know some few basic on programming, but you are new to Go. So we need to give you the Go way. Now move on to the next thing, which I call conditional statement. Hey, so that's what you call your if statement. It has even gone ahead to give us example. So let's just enjoy the example that is given. Now, our conditional statement is, you already know this one, is variable declaration of var is that. Again, this can be done in another alternative way by doing something like this. So you can just decide on which one works for you. So you could either use this or you use the long version. Anyone, you are good with anyone. Okay. So if you've done this, the conditional statement is fairly simple, just like Python. So I told some of you that this is like Python and a little bit simpler than Python. Um, this guy does a lot of things. It has a lot of tools that make sure that things are automatically formatted. When you go AWOL, it just returns things back to you the way it's supposed to be. Yeah, even though you have extensions that can do this for you, but this comes outside, out of the box, like so. Okay, so pretty straightforward. You have your if, whatever scenario, you can make if else and what have you come to play. So this is your typical conditional statement and how to make them. Okay, you can combine with other kind of condition. So by specifying the appressant, we have I'm gonna list out all the operators that we have. So these are similar to what you already know of. So we have not equal to, you have appressant, which is and then you have or. So this is making sure that this and this have to happen before this condition is executed. Then you could use the or one here, which is saying any of this, applies. If any of this is true, this should happen. You are already familiar with Boolean operation. true plus true is equal to what, false plus false is equal to true, all those scenarios, and the same thing play along here. So we're not going to be doing all those things here, but this is just for you to know how Golang handles its own conditional statement. Now moving on, because we have quite a lot of things to cover, so we cannot be going through each of these details, but your Python skills come in readily handy, available here. Your Python skills will actually go forth here. And the next thing I want to go through is conditional. Let me even remove this one. That's loop. Loop is the next thing I want to go through. I like the way this guy just give it to me. So how does loop work? Now, this is your, I think I spent a lot of time explaining this in Python. So let me try again and see how I can explain this time around in my comments. So we have three sections. Pay attention, guys. We have three sections here. Let me try and zoom it in so that you see. You have for, which is a keyword. Inside here, I'm gonna create like three sections. What can I use? Let me use this guy and this and this. So this is how I explained it the other time when I was doing this. So this is how it was explained. You have three sections here. One, two, three. The first section here is for initialization. So I just use IN. In fact, it has helped me fulfill the whole thing. You have your initialization section, you have your condition, and you have your incremental, bit. So the idea is that it's the same thing with Python, by the way. And I think it's the same thing with various programming language, even JavaScript. They all use this same parameter. So you are using your old, programming skills to solve, general problem. So you are good to go. Okay. So you initialize something here, you make your condition here, you increment here. And if memory serves me right, yeah, and there are other ways to also do loop. This is not the only way to do loop. This is one way, and we'll look at another way to do loop. I'm going to leave that on top there, and then we're going to look at another way to use loop. And this other way is going to introduce me to something I try to run away from, but that's fine. We'll take it. So, and that is struct. No, not struct. It's a kind of array. So we use array. So if I say I have numbers, I'm using the other method to initialize now, right? So this is the method I'm using. I like using this method a lot because it just, avoid me writing var norms, and I can now say int, right? This one is way longer. I prefer using this one. So what we've done is to have, this is the new stuff I'm doing. There are new things I've introduced here. I've introduced this guy. So this one is a way to specify that I have integer array, right? Integer array. And whatever is inside there is telling me that those are the data I have inside the integer. So I have like 1, 2, 3, 4, 5. So array is another story that you guys should by now know how to work with. Automatically, we have this method of looping through a fixed number of array, or a number of array that we have here. And the syntax is fairly straightforward, and it's different from what we have here, right? It's different. So this one has what I call the index. So I will explain why the underscore is like this. And this part is very interesting. You guys should pay attention to what's going on. I'm going to write this function again, or rather the loop again in two form, so you see the difference. Now you will notice this integer here that is written. I didn't type this int. It's automatic. It's automatically typed. Now that works like that because it's trying to tell me what I'm doing. Sometimes you see it in a function. When you call a function, it's like in the background. So it's not me typing it. It's just for you to give me a visual representation of what's going on. Okay. So I have this guy here, this one method. Now, whenever you see underscore in Golang, it means you are ignoring the value. Very important, guys. Whenever you see underscore in Golang, it means you are ignoring the value. If you don't ignore the value, in this case, let me say index, it's going to give you a problem. Say, hey, you said for index, most times we use I, right? So look at this I as a form of counter. So that's the same thing as this one here, right? Follow me, guys. So what you've done here is that you've request a variable, but you did not use it in your process. You did not use it to do anything, and hence it's giving you a underline, or rather, it's giving you an error. So in this case, you can just use it by just saying I like so. So if you know that it's gonna be useless into what you are doing, you can then use your underscore. You will see us use underscore, more frequent as we go on, because Golang is not forgiving. Not that it's not forgiving. It tries to make sure that everything that you declare, you are going to use it. Don't just put a variable they are not going to use. It's useless to everybody. So you must use it. Okay. Now I've introduced something new. Two things that are new: array, which I introduced here, and also the underscore. You will see it more. Okay. Let's go away with this one. This is also a way to loop in Golang. Moving on to the next thing. And the reason why I'm introducing all this is that we want to start building our REST API. And before we go ahead and start building REST API, I need to give you the fundamentals. And that's why I'm going through all this. And the next thing we want to do is to show you how to write a function. How do you write a function? Well, automatically, we should be able to know how to do that. That's the first thing we did when we started. This is a function, and that's like no brainer. Very simple, very easy, and it gets the job done. But of course, you know that this is not everything about a function. You are not seeing the true picture of the whole thing now. Let's get going and see if we can, show you the true picture. Let's try the function to add two things together, two numbers together. Okay, which one should we do first? We implement it before doing that. So let's print and say, okay, let me do it this way. Result is equal to add 1 plus 2, right? So, and then say my result is equal to result. Okay, we have two things missing. I like the fact that it has gone to write the code for us. But let's write the code ourselves so that we don't get too lazy. So it has written the code for us. But that's fine. Let me explain the code. And that's the thing about AI. And I think I have a course on AI that you guys should subscribe to. The idea that AI can do everything does not trump your thinking capability. You still need to be able to think, and that's where what will be lacking in the years to come. There'll be lacking people that can think critically. Okay, so let's move on. Notice the A that is here. If you notice in the for loop I wrote, there were some things written in gray that show forth, and this is very important. It makes your function clearly seen. You can read out what your function is. I'll make it more obvious. You're going to see what A and B would translate into in terms of renaming this. Now, how does the function work? You use your func keyword, which is here, similar to this. Then the name of the function follows, which is what we've done here. And the next thing is you pass in your parameters. The parameters are passed in next, followed by what you should return. This is the return. This one does not have any return um, parameter. So it returns empty or void. Okay. Then if whatever you want to do in your function, you do it. And when you are done, you return the exact same thing that you have here. Okay. That said, let's move on to the next thing, which is what I wanted to explain here. Now I can do this and say first value, and I can make the other one second value. So look at our function signature again. You can see that it's kind of looking nice. It's kind of making it easy to read and yeah, nice to look at. I like this. It looks beautiful. So make your arguments, parameter, make them make sense. Let them have a something that you can easily relate to. So I can say V1 and V2. That can be a thing as well. That can be a thing as well, and then you have this. So this is how to write a function. We're not even testing our code, but trust me, our code is gonna run perfectly with no issues. So, but just to make sure that our code is running, let's give it a try. And we know we are still using air. In our last video, I did mention that we use air. So if you just do air, you have your result right there. And where's our result? Okay, our code did not execute. Did it execute? So our air is not executing, but that's fine. I'm gonna use our old method to run this. And we remember go run main.go. So if you do that, you should have your result there. Our result is 3. Now, before you can use your air, you have to set up a couple of things. But let's go ahead with the old school method. So go run main.go gives us our result equal to 3. Just to show you that our code is working, and that we're not just writing gibberish. Let's move on to the next thing. Now, our function is done. Even though this function, there are still more to it, but I don't want to complicate things. When we get to another part of the course, we're going to talk more about this function. And that is when we get to struct. We should get to struct very soon. The next part we want to go into is error management, handling of error. How do you handle errors in Golang? How do you handle error? So before we get into that, let's look for a scenario where we are going to get error. What scenario can we simulate? There are different kind of errors. There are errors that are prone based on system based, like things that are not possible to be done, and there are error that you want to generate yourself. So we have a function that says add. Let's go ahead and create a function that says divide. So divide. I know I can write. I can just divide myself. I don't really need to write a function for dividing. Okay. So we have this. This is gonna give us. There are several scenarios that I can begin to paint in my head that is going to generate an error. But let's not be too hasty. Let's just go ahead and do some stuffs. I'm not gonna use add. Let me let's do for division. So we already have this one. Okay, let's reuse this. Now this also give you another example or another way to use assignment statement. Even though we've gone past beyond variable, this is a good way to explain one or two things to you. Now, what I have here, we already understand this part, which is addition. Now notice what I'm doing here in the second part. I'm still assigning what I'm doing here to result. But look at what I have inside the equal sign. The equal sign here is not having the semicolon. The semicolon is used to create a new instance or to initialize it for the first time. The reason why I'm not having semicolon here is because result is already a variable that is available in memory. So if I do this, I will get an error because I've already created the result variable. So I can't recreate it and reassign it again. That's why it has to be like that. The only way that you can go away with having this is to have another result 2 or result 1. So this one becomes a new variable and the new variable is attached here. But if you want to reuse this variable, it's fine. But I think it's anyone you want to do is left to you. So I will say addition results, it's here, and this can be division results, it sits here. So they are having different results. So I will say A results. So now I'm using proper variable naming to match the whole thing. Then I'll say D results. So that serves that purpose. Okay. Now the next thing is to let's even test it to make sure that our code is running. We've not gotten into the error yet. So let's run that. I do go main go run main.go. So we should see our program execute nicely, right? We have these guys working. So let's try and do some things that are not clearly okay. Like if you try to divide 10 by 3, we should get, let me see what we're going to get, if it's going to run very well. So we got the results, no errors, because definitely 10 divided by 3, of course, the answer is not 3, but we didn't get the exact answer we're supposed to get. Either you are getting maybe here we are getting 1, but of course, we know we're supposed to get like a decimal based stuff. And the reason we're not getting that is because we didn't return our return is not in float. Our return is still in integer. That's why we're getting an integer result. So what can we do to this is by saying, hey, return, at least return a float so that we can get something that is meaningful here. So that means that whatever we're going to do here, we'll convert each one of these to a float and divide, we should get our float as a result. So if I do this, we should have something like this in place. Okay. Now that we've done this, but we've not started looking at the error thing yet. Just stay with me. The next part is to try and divide it by 0, which we know mathematically is not possible. We can't have a value divided by 0. So let's run it and see what we're going to get. So if we run it, we have an infinity result there. I'm trying to trigger an error out. So let me do 0 divided by 10. I'm trying to generate a system-based error. Okay, so I think we're going to go with 10 divided by 0, which gives us that infinity. Now, most programs will actually give a very, very funny error. Like they will give you an error that will break the system. So how can you avoid people doing division by 0 with your code here? How can you do it that they can't divide by 0? And by the way, before I continue, let me put it back to integer. I'm having a feeling that it's supposed to actually give me a serious error. Let me check why it's not giving that error. So 10 divided by 0, let me check it again. Okay, yeah. So the reason why it was not giving me that error was because it was a float, which is kind of funny because I was still supposed to get that error. Now, if you do 10 divided by 0, it gave integer divided by 0 error. Now, this one breaks your system. You don't want your system to be broken like this. You want to be able to catch the error that is happening within your application. And that's where we are going now. How do we catch an error within our system such that we know what's going on? Okay, when you build a function, just like the way we built this function, you can actually predict or try and watch out for error and expose the error in such a way that you can manage it. Okay, what do I mean by that? This division returns integer only, a way for you to be able to also return the error that happens with it. When I mean returning error, this is not the ideal thing for what I mean ideal. If you are used to other programming language, you don't return your error, kind of. The error just happens, you just catch it. The way Go does its own error thing is a little bit different. Now, if you are calling this division like this, you want to also check if there's an error with it. Now, because we're the one that wrote this division, we can actually write another return an error function, or let's say error object. That's the way to put it, error object. But this time around, I'm not going to let AI do the work for me. So I want to write it out so that you guys will see it. So when you do it this way, it means you want to return two things. I'm going to put this in brackets. So we're returning two things. the first thing you are returning is, and the order is very important. The order in which you are returning them is very important. Your error is the last thing you return in terms of the ordering of things that you are doing. Error is the last thing you return. Now, let's try the code to do the returning. At what point should error occur? The error should occur when our v2 is equal to 0. So I'm already used to using these braces, but in Golang, you don't need to actually put them in braces like this. Automatically, it just works this way. So if v2 is equal to 0, that is when I want to return this error. I want to say something about this error and return something to the person that is calling it. Okay. So how do you return that? When you are returning, you need to return the two parameter. The integer, number one, will return 0 because you need to return something on it. And the other thing is you also return the error name or error value. So you now have error. No, that is even the wrong thing to do. You can either return it this way, or so you have various forms in which you can return it. You can use this method, errors.new, or you can use fmt error. But this one looks slick, right? Now, notice what happened in the second part. If your code gets to this part, it will terminate. But what if this part does not get executed? You need to be able to return something here, because what this one only return is just the integer part. You are not returning the full section. So to return the full section, you specify comma, just like as I've returned 0 and this here, you will now return nil. The nil you return is that, hey, no error was found, so we are good to go. No error was found and we are good to go. That's what you just did here. Now let's look at how to use it. How do you use this part? Now automatically this part is not aligned anymore. This part is what? It's not aligned anymore because it returns two things, but you're only accepting one thing, which is wrong. So you need to collect all the two things. So one of the way to fix this is to put the underscore. Remember I said something about underscore, that anytime you don't want to use a value, you just use underscore, and underscore will just ignore the value and just continue. So if you write this code, if you run this code, the system will just pass in 0. It will not give you any error. It will just put 0 here. Let's go ahead and see and just do that so that you see what I'm talking about. So if you run this now, you will just have 0 there. But what has happened? You've not been able to tell the user that, hey, something bad happened. So we need to be able to capture the error. And how do you normally capture error? By giving it a variable name. So now that a variable name is inside here, you need to make a conditional statement to see when there's error and print the error to the user. Okay, so now that the variable is here, you will now write this piece of code, this small piece of code. As long as error is not equal to nil, print out this. So when the error contains something, print the error so that the user will see the error. So let's give it a try now and check. So if you now do this, you now have the error saying that, hey, division by 0 is not allowed. Whatever you wrote here is what will eventually be shown to the user. Division by 0 is not allowed. Okay, now what I've been able to do right now is introduce error into the system. What I mean introduce is more like error handling error. So let me do a recap quickly. First of all, I've been able to show you how to include error in your function. Error handling. There will be points whereby you need to express and say, oh, this part, there's an error here. So that whosoever is consuming your function will do the due diligence of implementing it properly. And in so doing, you have to add the error object, at the end of your return parameters. So you can actually have more than one return stuff. Okay. And at each point when you are returning then you have to return nil if there's no error. If there's error, you return the error and you are good to go. And in the point of consuming it, is either you use the error, it's advisable to watch out for the error and use it. And this is a general practice. You will see this across board. You will see this across board. This is how Go handle its error. It consumes, does something, it checks if there's an error, and it does what it needs to do. At this point, there are several things you can do. You can either, escalate, do some things, reverse some cases, whatever it is you want to do. This is the point to do that. This is where you do all those things, right? So, for example, now I can just do something like this, and then this become what this needs to be. So, if there's an error, it does this, and it doesn't need to say anything division result, else it does this. Okay, that is division, or rather, that's error handling. Let's move into the next thing. By the way, this error thing, you will get to see it in a lot of places. So for now, it might be looking kind of dramatic, but don't worry. As you go on, you will see it. In fact, it's so rampant that people kind of, this has become a signature thing as far as Go is concerned. It's one of the things that you'll be writing more. You'll be writing more of this. This small thing that you see now, you'll be writing it more a lot. The next one we have is structs, packages, and modules. That's what we're doing now. But let's start with structs. So I'm going to clear everything, kind of, so that we'll have another, like a fresh start. Not really a fresh start to say. So you can say that because we use errors, it imports error stuff for us so that we can make use of it. Now, what is struct? Struct is a kind of a data type. Yeah, you can say struct is a kind of data type. And in other languages, you refer them to as objects, even though here it's not called object. It's not called object here. I'm going to create a sample struct, and to create it, you say type, right? And then the name of the struct, you want to call it user, and you use the keyword struct. So we have the keyword struct followed by this parenthesis, and you can then go inside and add um, the data that you want of the properties, as the case may be. So here you have the ID, the name, and let me add email string. And I'm going to explain what's going on here. Remember, I told you that this some languages call it object. Well, not like some, depending on what it is. In Golang, there's no object. It's not like it's not OOP. So they call it struct, and you create by type the name of the struct and then the struct keyword. Okay, so how does this work? There's quite a lot of things that goes in here, a lot of things, but this is like the bare minimal, right? This is the bare minimal. So you can make some things private by using small letter. So when you do something like this, it's not available to other people. It's private to this particular, so the field is private to it. It can't be exposed. So, but we'll take it gradually. Okay. So this is a standard struct. And why would you want to do this? Something like this is such that you can be able to group related fields together, right? So for example, now this is a typical example. So this is us creating a user. We are creating a user and we are assigning it. So look at the creation method. Remember this method. So there are other type, which is user. So let me say user one, and I can say user. Just so you see the different type of creation methodology that we have. So you can either use your var, like I mentioned, or use your column. So for me, I like using this method. Again, you can still print what you've done. So I will just print my user like that. And this guy is, you know, able to print it as it is, destruct like so. Now, what are we doing here? We are creating a new instance of user. Remember, this is not an object. They call it struct. but you can, if you are coming from OOP background, you can still look at it as a form of object. Yep, you can look at it in that form. Okay, so you can actually print out a particular part of this particular user. So you can say, you can access it by using the dot notation and say you want to do this dot email. So you could literally just say user dot email. And this user is this struct that you have here. And by creating an instance of this inside here, you could access any part of this. So what we just did here is initialization of the data. So it's the same thing as saying A is equal to 45. So what we did here is the same thing as this, because now we initialize what ID is to be 1, name to be this, and this to be this. If you don't want to initialize the value to something, you can just do something like this. If you don't want to initialize with anything, you can do something like this. And what this does is that it makes it blank. So what you've done here is that you did not define a default value for ID, name, and user. So user 1, let me call this user 1 and this user 2. So this can be user 1.email and this can be user 2. Okay. So if you print both out, you should see different results. The first one will come with the data that you've populated it with. The second one comes empty because the data was not computed. There's no data in the second one. Let's even try it out and see what we have. If we run and let's see our results. So let's use our proper FMT. So let me use the proper print library to print it out so that we'll have proper results. Let me try it again. So if you look at it, this is the first result, which appeared the way we want it should be. The second result goes this way, and it shows this one. Now, I think I want to introduce, I don't know if it's the right time to introduce it, more like a pointer. I don't know if this is the right time to introduce it, but I will try to introduce it a little bit. I will try. So now this is the definition of your, this is the structure, right? And anything that you do from here on is being taken from the fact that you have this. And there are instances, now when you saw this one now print, notice something. Notice that this one gave us 0, which is kind of odd. Because where is this 0 coming from? We didn't set 0 at any point. We didn't set 0. So why did he put 0 there? Because that's the default value that comes up in a number when the number is not defined. Just the same way when name is not defined, a empty string will be used. So there will be some points whereby you don't want anything, don't put anything there. I want to have a null value. If you don't know what null is, just write it down and go and Google it. So even though we've mentioned null several times, null is non-availability of data. Nothing was ever captured. I think that's the best way to explain what null is. Okay, so there's this pointer you can set this way, and this will cause another long story. But I'll just try as much as possible to help out. So I'll create two data. We have the ID. What other ID can I use again? ID2. So let me use the word ID2. And then this time around, I'll make it a pointer. So you get to see the difference in it. So if we print, that would be very difficult for me to, but let me see if it will allow me to provide ID2. Now ID2, I've provided ID2 to be 3, but it's not working. Long story short, so I think you should be able to take 2 like this, yes. So this new is a new um, is a new function. Yeah, this just came out. Just came out. I'm not going to go into details. Just came out. But this is how to do it. Now, why are we using the new keyword? And why is it not accepting for a number? The reason why it's not accepting a number is because it's a pointer. So you need to use the new pointer to access it. You need to put this to access it. So we'll find another time to explain this pointer thing here. But there's a reason why I'm bringing up this up now. So let's run it and see the difference. So if I run this guy, I have this result. Now there's a reason why I'm running this, and it's very interesting. So this will give you an idea what's going on. So if you run these two guys, the first one comes up with 1, which we know here because that's normal. The second one came with 0 because it's an integer and there's no value, so it will use 0. And look at what's happening to ID2. ID2 is bringing in this gibberish. Now this is the location of where um, 4 is in your system memory. That's what is happening here. So it's pointing to where it is in the memory. So in the second case, it's nothing pointed to anywhere. It's a nil. So that's the small explanation I will give you guys for now. Small explanation for now. So we'll cover it later as the course persists. But I just had to introduce this pointer thing. You will get to see it much more in the future. Now, another thing you need to also get to know is what I call struct method. Struct method. And they call it function or methods in object-oriented programming. You see those method thing going on. So there's something like that here as well. So you should be able to do things like user one dot delete or something, right? So you should be able to do something like that. So how do you do something like that? Now you can do that by using the struct method I talked about. Method are function attached to struct. Methods are function attached to struct. So it means I can actually create a function separately and attach it to a struct. So let's create a function, and that function is just to display. So instead of us printing something like this, right? So I'm gonna copy this out. I want to write a function to display. Let's let's remove this and let's create the function and call the function display so that we can then write our fmt print and then display the user. And the problem now is that how do we get the user information? That's the problem. Remember that we want to write the function and attach it to, let me just make this one, let me just call it user like this. This is just a string. So we want the function to be attached to a method, very important, or rather attached to a struct. The method has been written. How do we attach this written method to a struct? Very simple. We have to come to the front of the function declaration and open a parenthesis and add a variable name and use the name of the struct to hold it like this. This is how to do it. So the only thing we did was to come in front of here and use the variable name. This can be anything. The reason why we use u is maybe because it's initially you can call it anything. And the idea is that you can now make use of this u inside of your print statement or anywhere in your function body. So I can say u dot anything. I can do this like this. So that it looks nice, I can do something like okay, let me write all this big jargon. Okay, so automatically I can do something like that. So this way it will look nice. Now, how do I use it? Remember that this display is now attached to the struct. So I can do something like user one dot automatically I now have display. User one dot display. I can then do something like this again. User two dot display. Now this display is not available to anybody. Anybody cannot just come and use the display. The only person that can use the display is this guy. So let me even put them together because it's too far apart. So the only person that can use this display is user. So you can see that we're getting somewhere. Let's test it and see what it does. If I come here and I write my run code, so it's making sense now. So you have the display run like this. It's called this. And because we didn't initialize or we didn't set anything here, it just came like so. So we're good to go. We now know how to attach a function to a struct. Let's move on to the next thing that we have, which is packages. Now that we have all these things, going on for us, because as your code become increasingly large, you need to be able to package your code very well. And that's how we have this. So we will not be talking too much on packages because we will be looking at that when we go to, or should I introduce it now? Okay, let me introduce it quickly. So if I come here and we already have main.go here, I can create a folder and call it user. And the idea is that, or let me call it utility or anything, sure. Let me say others. And the idea is that I want this user to be in that place, right? I want it to be in that place. So how do I go ahead and do that? I will need to create a file here and call it anything. Let me just call it user.go. So notice what happened. The package name automatically, gave it orders. Automatically gave it orders. So because of the folder name. Of course, you can change it, but most time it's good for you to match that thing that is there. Okay, so let's move on. The intention of this page is to carry not all the code, all these guys here, this one here. We want to move it to the user. Now, the intention here is that you will be able to import this code from your main. You want your main to be able to use all the code. And so how do you use that? Automatically, you can see that the AI is trying to fix it for us. So a way to do it is because these are our roots and your folder is here, others, you can use others.user. You will be able to access it. So once you use other.user, you'll be able to access it. And then once you save, it should fix it. But unfortunately, it's not fixing it because it needs to be able to import it, know how to import it. Now, another reason why it's not knowing how to import it is because we've not created a Go module. But let me try. Let's try to see if we can import it. So normally we're supposed to be able to do import, and our importation will be based on our folder name. Now notice what you are seeing there. Automatically it's using all these things as a folder name, but this is how we are structured for now. So this is how we are structured because our folder name is called API/others, and it's supposed to be able to know what to do and bring everything to play. But unfortunately, it's still not doing that because of the next thing we need to do, which is modules. We need to create module, that's Go module. And how does that work? In the previous class, we mentioned that we just come here and create a folder called Go mode. We can create the folder or we go to our terminal and initiate it. So there are several methods. We go to our terminal and just say Go mode initialize. Don't forget your product name. It has to be in front. I mentioned that there are several ways you need to go about this. You can use GitHub blah blah blah.com product name and things like that, or just the name of your folder. So in this case, we just use our folder name. Later we'll change it. So look at the pattern. Go mode initialize API. Boom. And then it does what it needs to do. Automatically everything has started working automatically. So let's look at things that it did. The first thing it did was to create a Go mode file, which is here, which we've covered before, and it did module API. This API is the name of the folder Yep, name of the folder. And if you come here, we've already done that. If we delete this one now and I save, it will automatically import everything, knowing that that's the right path. So that has introduced you to packages. I've been able to write code outside of my main. This is your main. Now I've written outside of my main, and I was able to consume it inside my main. So we can actually test that to see that it's working. You know it's working because it's not giving us error. So all is good. Now, the next thing we need to do is to introduce another thing new, which is JSON and HTTP. Very important. We're getting there, guys. We're getting to the point where we're going to be using our gene. Working with JSON and HTTP. By now, you should know what JSON is all about. JSON is um, JavaScript object notation. So you should know that and how to define one. So if I just open a random file now, I can just say a.json. So this is a JSON file. This is a JSON file. So that's a JSON file, guys. Very easy. Your value, your key, and your value, your key and your value, and your value can be under JSON object. So you should know how this works, right? If you don't know JSON, please go and check out JSON. So I won't cover JSON separately. Okay, so we already know what JSON is. Now, you know you can actually convert this to JSON. Not necessarily convert it to JSON, but make it smart that JSON understands it or they understand themselves. Very, very important. You'll be like, really? Yeah. You can actually make these guys smart enough to be able to understand JSON. And you'll be doing that a lot in your API. How does that happen? So there's something we call tags, that you can apply to each of the fields. So these are fields, guys. These are fields. So you can actually attach a tag to each of these fields here. And that can be done by doing this. In fact, he already knows what I'm trying to do. I don't know, maybe he's reading my mind or something. So I'll just implement everything and then you guys will see. So let me explain. So if you use this sign here, it's called backtick or something. Once you introduce it, you can then write JSON and specify the name of the JSON value because this name here will be different from this value, might be. So the idea is that when you export this value, what name is it going to be called? Golang uses capital letter, while JSON ideally a small letter like this. Ideally. So JSON is like this. There are several different versions out there. Some use underscore, some use capital letter, but ideally it's something like this, whereby when new value starts, it starts with capital letter, like so. So watch out for this. This is the pattern I will be using. Again, may I use something like this ID, not not that ID. I use this ID instead. Okay. So moving on. Okay, it has seen a change. And you can see that how the whole thing is automatically wired to each other is saying that a change has occurred. If you make a change here, for example, it's going to, call you up that something has changed somewhere. And that's one of the important thing about Golang. It being compiled makes your life much easier and allow you to catch bug when developing than when you're live. Okay, now I've been able to tell you that you can do this, but of course, you've not seen the benefit yet. We are getting there. You've not seen the benefit yet. You are getting there. But just know that when you define something that should be available by the web, you will need to provide the JSON attribute to it. Especially if you are sending this to the front end, you need to provide this. Now let's look at encoding JSON, encoding the value and decoding it, right? There are some functions that you need to pay attention to, and that function you will use it across board almost every time you use it. So we can actually use this same example, right, to work with it. So even though we're not going to be calling display, I'll be using something else. I don't think we'll be calling display. Let me just use this one that has one, and then we'll remove the two out of it. Now, the thing we want to call right now is what we want to call right now is a function in JSON, and it's called Marshal. Yep, it's called Marshal. So let's see how Marshal works. I'm going to remove this one, and the data we want to return is, I'll say JSON. This guy is even reading my mind. JSON data, but that's not what we want to do. And is equal to JSON. So JSON itself, yeah, that's what we want to do. The Marshal guy is what we want to do, and I'll explain what Marshal is all about. So I'm gonna save so that I can import this JSON thing for you. So this is a core thing. This core to the system. This is our own that we wrote to bring in user. Why this is to format. FMT is to format our result into the console. You need to understand everything that the system is doing to give you the full blown experience. Now, what is Marshal? Marshal is you bringing in a value and converting it to JSON. So you see that two ways. It transfers a value into, JSON format. So imagine you have an object. You now want to convert it to JSON for whatever reason. So you can do it this way. Now remember the underscore, right? So at this point, this is when you want to, not that this is when you want to, but you can actually, if there was an error, you can actually spit out the error into the console so that you know what's going on. So here, most times when you ignore errors is because maybe you know that errors cannot occur because you've already done some check. Or if you know an error can occur, you don't trust what is coming by the user. This is when you now say error, like I did it the other time, and do a check and then print out what the error is so that you know where to go and fix whatever. Okay. So for now, we are not actually printing out the error. Now, what we are doing is just to show you how to use Marshal. Marshal is converting a JSON into a data into JSON object. And there will be reasons why you want to do that over time. You will see the reasons why that needs to be done. So let's see how the output looks like. So I'm sure this should look familiar to you. You see that it's a JSON object compared to all what we've been exporting since. All we've been exporting since is just, let me export again so that you see the difference between both of them. This one here is just uh, dumping. There's nothing wrong with it, by the way. It's just dumping data from user one, and that's Golang just dumping of data. While this other one it's literally JSON. This is JSON literally. While this one is just data dumping, right? Just console dumping. So those are two different things because there will be instances where you want your data to go in as JSON, not as any other thing. So that's how to use JSON, but that's encoding data into JSON. There's also decoding, which is turning data into JSON. So, but for now, we will not be looking at that. We'll not be looking at decoding. Now, let's look at HTTP. HTTP is very, very interesting, but I think we should look at it in context of Gene. But before we get to Gene, let's look at it in its pure state without being adulterated. Now, let's look at it. So we've taken too much, but we will not go into Gene today. But by the time we are seeing Gene the next time, everything should now be making sense. Okay, let's look at Let me clear all this and show you net/http. So this one is a little bit interesting because it comes with quite a lot of stuff that is might looks confusing. So for now, I'm gonna clear all these things. So because I want to show you guys new stuff. This new stuff, guys. Let's go ahead and start. Now this is HTTP, and what is that for? This is, in fact, it has gone to do its thing for me. No, let me not use his own. His own might be so confusing. So HTTP is to handle requests from the browser. And the first function we do is use is the handle request or handle function, right? So when we say handle function, it requires two parameters. The first parameter is the endpoint. We talked about this. So I'll just say hello. That's the endpoint, meaning when you go to your browser and do hello, you are expecting something to happen. So in this case, I want to call a function. I will say hello handle, right? That's what I want to call the function name, hello handle. We've not written the function, but I'm still going to write the function later. Now, I will now want to listen to port 8080. Now, what this one does is that it allows the server to start. I think my port 8080 is in use. Let me use 1990 is in use. That's all. Well, not typically all. We still need to write the hello handle function. It's trying to write that function for me. Just come back. So hello handle function. We need to write the function. So let's go ahead and write it. So our function, let me just submit to the guy. The guy kind of the here word. Okay. So we have hello handle, and we have to this is a must. So it's not something that you can circumvent. So you have to write, it has to have a particular signature. When you are writing your handle function, it has to match this signature first. And whatever you write inside the document is on you, right? So this is how to write to the browser. So you are writing hello world to the browser. Okay. So the idea of Gene is to remove all these verbosity and make it more simpler. So we'll be talking about that in our next class. But before we enter there, let's test this and make sure it works. Let's start the server by just doing our go, simple go run main go. So once we do that, and once the server starts, it's going to let us know it has started. You have it there. Our server is on 1990. I think it was supposed to be showing us here, but no problem. Let's go and run it. Localhost 1990. 1990. Remember the part that we need is hello. So it's working. That is working. That's working. We are good. We are good. And that was very fast to write a server under 12 line of code, right? 12 line of code. You've written a server application that is working. Okay, let me see what else I need to talk about. Yeah, let me now use the air this time around. Let me use the air to run this guy. I wanted to use the air the other time. It didn't allow me. Let's go ahead and use air. Because now that we have the Go module, the air should work. So now our air is running and we have our server running. So we can do a kind of preview and our server is up. I can change this to hello and we have our hello world. Pretty cool. So if you want to introduce new handle like ping and you change this to ping handle, of course you need to create the ping function as well. So if you try to save your change, it will rebuild this. And when you come here and do your ping, you should get your pong. Great. We are good to go. So even though we've done something similar to this the last time, the point of this class is to give you the foundation so that by the time you are saying Gene, some things will not be, how will I put it now? Will not be new to you. So Gene is coming in the next class, and we're going to be introducing quite a lot of things. After Gene, we're now going to go to front end and be merging both of them together.